All right, today we are doing 1.5, which is segment and angle measure. All right, so our objectives today are to state and apply the ruler, protractor, and angle addition postulates. So we're learning a few more postulates. Use coordinates to determine distances. Classify angles by their measure. And apply the definitions of between, congruence, midpoint, and adjacent angles. So we got new vocabulary, new postulates, or rules, all kinds of things going on today. All right, so let me go ahead and scroll this down so we can just see a little bit more of our notes here. Okay, so we can start with the ruler postulate. The ruler postulate is simply that every point on a line can be placed in a one-to-one correspondence with a real number. Okay, all the ruler postulate says is that every point on a line gets a real number. Okay, that's all. The coordinate, you know this, again, algebra, we did coordinates all the time. It's just the number that corresponds to a point. So here, -5 corresponds to B. Okay, C doesn't have the number, but we can tell that it's -1. They correspond. They go together. Now, length of a segment. This is going to be important. It's the distance, you know that, between 2 points. Cool. But this is the formula you use to solve for the length of a segment. You are going to use that and apply it today. Okay, so if we want the length of AB, notice this does not say segment AB. Okay, there is no line on top when we're talking about the length. We just have AB, no line. So the length of AB is equal to the absolute value of A minus B. So we're going to apply this because we're going to put the numbers in there for the lowercase letters. So find the length of each segment. And the only reason this one says, right, it's saying segment BD, so we're supposed to find the length. So then we would rewrite this and say, well, BD is equal to the absolute value of B minus D. Okay, so then B is -5, so this is going to equal the absolute value of -5 minus D, which is going to be here 0, so 1, D is 2. So the absolute value of -5 minus 2 equals the absolute value of -7. The absolute value of -7 is 7. So 7 equals BD. All right, for segment AE, well, that means we're going to do the length. We're going to find the length of AE is going to be equal to the absolute value of A minus E on the number line. So A is, okay, here, B is -5, so -6, -7, -8. So the absolute value of -8 minus E. E is one more past 2, so that's 3. So -8 minus 3. -8 minus 3 is -11, so we have the absolute value of -11, which means length AE is equal to 11. All right, last one. Find the length of segment EC. Okay, so the length of EC, so again, no segment symbol, equals the absolute value of point E minus point C. All right, well, point E is 3 minus C. Okay, C is -1. So 3 minus -1 equals, remember, two negatives or a double negative there like that makes it plus. So this is the absolute value of 4. So the length of EC is equal to 4. All right, so that can be a little bit confusing, remembering the difference between a segment and length, but also very important for you to notice and pay attention to. All right, so congruent segments then are segments with equal lengths and they're denoted with this symbol. So it's just an equal symbol with a wave on top. Or if you're taking Spanish, it's a tilde on top. But that's congruent. And what it means is the segments have equal length. So we might pick some segments. We might say segment MN is congruent to segment JK. Okay, so that would be an example of that. All right, and then fortunately our little timer is in the way there. Let me move that a little bit. Oh, that was a lot of it. So then our timer says point B is between points A and C, notated A-B-C. So we talked about between, but this is super important. We talked about this yesterday though. So between, and remember it's always notated with this A-B-C. And also we now know if AB plus BC equals AC. So remember this is the length. If the length of AB plus the length of BC equals the length of AC. So these are lengths. Okay, so we're not talking segments, we're talking lengths. Lengths are equal, segments are congruent. Slight difference there. All right, so let's clear this and move on. Okay, so example 2. It says find length AB and length BC if length of AC is 75. So remember, this is length. Let me change my color. This is length. This one, okay, all of these are lengths because there's no segment. All right, but the cool thing is it's telling me length AC is 75. So from A all the way to C is 75. And so we get to do some algebra. Woohoo! Okay, so what that means is if, just like we talked about, if I add from A to B, so if I take, I'm going to write it over here, the length of AB and I add it to the length of BC, I should get the length from A all the way to C. Right? That's what between is. B is between A and C. And you're like, duh, Mrs. Talbert, I know this. Okay? But we have to put it in mathematical terminology. So we can write an equation. Okay? Because now we can say, okay, well, AB is equal to 6x plus 1. So we can say, all right, well, 6x plus 1, that length of AB, plus the length of B to C, which is 5x plus 10, has to equal the length from A to C, which we know is 75. All right. So the only reason I put these in parentheses, right, are because they are showing, the parentheses are showing like this section plus this section. All right. Because here's the thing. You learned a lot of rules in algebra on how to do the math and to break some of the rules, right? We can't add 6x plus 1. That's okay. We have 5x plus 10. We learned that we don't actually have to add the stuff inside the parentheses. We just have to add the like terms. So we would do 6x plus 5x is 11x. And then 1 plus a positive 10 is 11. Hold on. 6x minus 1. I was like, something is wrong here. I wrote this down wrong. I apologize. I usually catch my mistakes. Good thing I did here. So 6x plus 5x is 11x, but negative 1 plus positive 10 would be plus 9. That's correct. Equals our 75. So we have a more simplified equation that we're going to keep working on and balancing to solve. So we're going to subtract 9 from both sides. 11x equals 66. Divide by 11. And x equals 6. Okay, so great. We know x is 6. But that still hasn't answered our question. We have to find the length of AB and the length of BC. So we're going to plug the 6 into each of these, right? So AB is equal to 6x minus 1, which is 6 times 6 minus 1. So 36 minus 1 is 35. And I guess I should have done that in blue Sorry, I didn't quite color coordinate. I will do BC. So the length of BC, actually, let me move that a little bit. I'll do it over here. So the length of BC is equal to 5x plus 10. So it's going to be 5 times 6, because that's what we found out x equaled, plus 10. So that is 5 times 6 is 30, plus 10 is 40. So BC is equal to 40. Okay. And you can always check, right? So if this is 35 and this is 40, is 35 plus 40 equal to 75? Yes, indeed it is. So you know you did it right. Okay, another definition. So one, point M, okay, is called the midpoint. It's always a capital M, always, always, always. And it is a midpoint of segment XY if X, it's X dash M dash Y. So if M is between X and Y. Okay, so the midpoint obviously has to be between the two endpoints on a line, just like this one. And the other thing, so it has an and, XM, so the length, okay, these are lengths. The length of XM is equal to the length of MY, or these are segments. Segment XM is congruent to segment MY. So lengths have to be equal, or segments are congruent. Okay, so we have to have lengths equal or segments, I'll put an S on there, congruent. Those are the terms that we're going to use with that. So let's look at this box. It says, is B the midpoint? So let's go back up here. Is B the midpoint? Well, we do have A and then B and then C, like B is between, so awesome. B is between A and C. But do we have equal lengths? No, right? AB, length AB is not equal to length BC. So B is not the midpoint. So no, B is not the midpoint. Okay, we can't have that. All right. Then let me clean this up and we'll scroll on down. Then we have this protractor postulate. All right, in the protractor postulate, again, it's just saying that any angle A can be placed in a one-to-one correspondence with a degree measure less than or equal to 180 degrees. So, right, it's just saying like any angle is going to measure less than or equal to 180 degrees. Again, these are things that you know. We're just putting it into terms, into vocabulary and refreshing your memory. So remember that acute angles are between 0 and 90 degrees. There's a right angle that is exactly 90 degrees. An obtuse angle is greater than 90 and less than 180. And a straight angle is exactly 180 degrees. All right, because we're going to use that on the next problem. So flip over to the back. All right, so on this side, we want to find the measure of each angle, then classify the angle as acute, right, obtuse, or straight. All right, sorry, I had to write a note. All right, so if we look at angle BAC, okay, so we're going from B down to A over to C. All right, we want to measure. Notice we have to, like this line is on 0, right? That's helpful. And it's going up along here. Is it going on the outside though? No, because that's on the outside, that's 110. So really, we could draw the line inside. It's going from 0 up here to 60. So angle BAC is 60 degrees. All right, so is that acute, right, obtuse, or straight? Well, it's less than 90, so it's acute. You know, your elementary school teacher might have called it a cute little tiny triangle. I don't really do that. All right, next up is angle EAB. So here we have E. We're going over to vertex A and up to this endpoint B. Again, this line has a 0 on it right here on the outside. So if we follow that all the way around up to the other endpoint, okay, what measure is angle EAB? Perfect, it's 120 degrees. All right, is 120 degrees acute, right, obtuse, or straight? Well, it's greater than 90, so it is obtuse. Excellent. We're moving right along. All right, next up is angle BAD. Okay, so B to A to D. Oh my, neither of these is on the 0. Okay, so we're going to have to do a little bit more work, and that's okay. All right, in order to do that, we're going to just find the absolute value of these distances. And you can go either way. So if you want to start on this side, okay, or let's see if we can, it doesn't really matter where you start. So you can, but you need to pick and just go with it. All right, so remember that the length of our, the length of AB was the absolute value of A minus B. It's the same thing, same premise here. The measure of BAD is going to be the absolute value of the two measures. So 30 minus 120. Okay, so 30 minus 120 is going to be negative 90. The absolute value of negative 90 is 90 degrees. Okay, which means that it's what type of angle? Acute, obtuse, right, straight. Great, this is right. Now, the other thing, like with the way you're doing this, you could have picked the other ones. You could have picked 150 and 60. So you could have said the absolute value of 150 minus 60. Let me make that a little bit bigger. Well, 150 minus 60 is 90 degrees. The absolute value of 90 is 90 degrees. Either way, does not matter. If you would have flipped them and you said, oh, I want to do 120 minus 30. Great, that equals the absolute value of 90, which is still 90. It does not matter if you're using the right formula. It's the glorious thing about math. Okay, next up, congruent angles. So congruent angles are angles with equal measures. All right, equal measures. So like here we have X and Y. This one's 60 degrees, this one's 60 degrees, they're congruent. All right, so we are going to say that angle X is congruent to angle Y if this means the measure. Okay, you'll see that tiny little italicized M. If the measure of angle X is equal to the measure of angle Y. This, again, the way you're denoting these things goes back to where we talked about how segment, like segment XY is congruent, we would say, okay, to segment YX. Or we could say the length of XY is equal to the length of YX. If we're talking about the measures of them, okay, we talk about how they are equal. If we talk about congruence, okay, or things, then we're talking about the segments or the angles. So they're very similar but slightly different. So you do have to pay attention to those slight differences. Okay. Next up, we have adjacent angles. Adjacent. What does adjacent mean? Adjacent just means beside, right? Like maybe I am beside the desk or you're beside another student in class. Adjacent just means you're beside, you're next to it. So adjacent angles are angles with a common side. They're side by side. Okay, but they have no common interior points. They have a common vertex, and they also can form a larger angle. So if we look here, this angle, MNK, is adjacent to angle KNP. Okay, so I'm gonna go ahead and write that down. I'm gonna say, well, angle MNK is adjacent to angle KNP. Because here's the deal. They have a common side. Right here, this is in common. And they form a larger angle. If we put them together, we would have angle MNP. Okay, we'd make a bigger angle. That's all. That's what adjacent angles are. Which also brings us to the angle addition postulate. So we have angles, and we're adding them. Ta-da! Okay, so it says if K lies in the interior, so if K is in the inside, then the measure of angle MNK plus the measure of KNP is going to equal the measure of angle MNP. So here's the deal, okay? If MNK is 10 degrees and KNP is 27 degrees, then the whole thing, okay, this whole thing, and I'm going to see if I can pick up that green. Oh, it didn't let me move the green. Okay, so I'm going to move this so I can see. So if the little one is 10 degrees and the big one is 27 degrees, then, or the bigger one, then the two of them together is going to be equal to 10 plus 27, which is 37 degrees. Again, you're like, I could have figured this out on my own. You probably could have. But I'm your teacher, so you get to listen to me. All right, so let's look at example 4. We're going to find the measure of angle 2. Remember that word, that M means measure. And the measure of angle BAD if the measure of angle 1 equals 55 degrees. Well, first of all, I'm going to come over here to angle 1, and I'm going to label that 55 degrees. Then I'm going to notice that these have the same marks on them. This has 2 loops or curves on it, and this one also has 2 curves on it. Okay, this means, since they have the same number, that they are congruent. That tells us that these are congruent angles. So what that means is that the measure of angle 1 is congruent to the measure of angle 2. Well, earlier when we knew that, or hold on, let me rephrase this. I wrote this a little bit wrong for you. So that means, let me back up, not the measure. It means that angle 1 is congruent to angle 2, which we know means that the measure of angle 1 is equal to the measure of angle 2, right? Well, if the measure of angle 1 is 55 degrees, then the measure of angle 2 is also 55 degrees. Ta-da! That's glorious. Now I can find the measure, because I found the measure of angle 2, I can find the measure of angle BAD. Because the measure of angle BAD, right, because BAD, I guess I should say, is the measure of angle 1 plus the measure of angle 2. So that's 55 plus 55. So the measure of angle BAD is equal to 110 degrees. And I'm sure that you are not excited about showing this work and writing these things out. You need to do that to practice and repeat yourself. This is why I am saying it as I'm writing it, to help you, to help it ingrain in your brain. The measure of angle BAD, right? The measure of angle 1. Angle MNK is adjacent to angle KNP. You're going to have to read this language. So practice it a lot in your notes. Okay, so something new tonight for you is this on your own. So these questions I'm not going to do. You need to do them on your own, as it says. And then tomorrow, or when we have class, I'm going to check these as well and go over them to just see like how well you understood the material in the notes. You won't have them every time we have notes, but more often than not, you should have them. All right, then I will see you later. Have a great one.